Good afternoon. Welcome to another presentation of the Open Mic. My name is Lisa O'Brien. I'm going to be your host for today's presentation. If you don't know me, I am an internal auditor at HQ and also a member of the Integrated Communications Group. Before we begin, I want to remind everyone that this meeting is being recorded and will be posted on WAPA's internal website. Audience cameras and microphones have been disabled to ensure a quality recording. This effort is brought to you today by the Integrated Communications Group. The Open Mic is a platform for all employees to gain deeper understanding of WAPA's mission, connect and learn from each other, and also strengthen partnerships and relationships across regions and functional areas. The Open Mic also provides a place for people to practice and expand their speaking and presentation skills. So today we are joined by Pete Miller from the Rocky Mountain region. Pete is a power system dispatcher supervisor, and he's going to be talking to us today on what is switching. If you have any questions for Pete, there is going to be a Q&A session at the end. Katie Bayshore, an administrative officer at Upper Great Plains, and who is also an ICG team member, is going to be hosting the Q&A session today. So you can go ahead and ask your questions in the MS Teams chat of this meeting, or you can also private message Katie if you're more comfortable with doing that. So with all that said, I am now going to turn the time over to Pete. Take it away.
Hello, everyone. Today's open mic is, what is switching? And one of the questions we ask ourselves is to switch or not to switch? That is the question. My name is Pete Miller. I'm the manager of the Operations Support Group here in Rocky Mountain region. And so we're going to talk a little bit about switching today. Here's a couple of things you can expect to learn. We're going to talk about the different types of switching. We're going to talk about hotline orders and how those are established. We're going to talk about the reliability and integrity of the federal power system. We're going to talk about clearances, what they are, and what kind of protection they offer to the worker. We're going to talk about general switching, what's its purpose, how's it used. We'll talk about switching with orders. We'll talk about switching without orders. We'll talk a little bit about equipment limitations. Anytime a person is switching, it doesn't matter if it's in a power plant, a substation, in the dispatch center, the system operator switching on SCADA, or if it's an electrician or lineman switching in a substation. Anytime you're switching, you got to realize that you have to follow the 6 basic steps of switching. The key to the 6 basic steps of switching is that you have to complete all 6 of these steps in order to get one step of switching completed. So the first thing you want to do is carry that switching program while you're switching. Then you're going to touch or point to the device identification nameplate to make sure you're in the right location. You're going to recheck the switching program for the correct location and the correct sequence. And then you're going to verify the anticipated device position. And then number 5 is you're going to perform the requested action on the device in a safe manner. And then number 6 is you want to make sure that you verify the desired device position. So if I was opening a disconnect switch in a substation, I want to make sure that I have all 3 phases open as directed. Here's one thing that we want you to realize, that no person will be required to perform switching or work on a job or equipment that they consider unsafe. If you're put in a situation where you're not sure what you're doing, it's best that you should stop and communicate to the system operator. So what exactly is switching? Well, for example, I could say something like, hey, Clint Barney was going to be the instructor today, but he had an issue and we had to switch out instructors today. That's one way to look at switching. I can switch from T-Mobile to Verizon. Another way is to look at it is changing the position, direction, or focus of something. Most of the time, our switching is done in an electrical substation. In this photo here, you see Pinnacle Peak Substation down in the Desert Southwest region. And in this substation, it's basically a high voltage electric system facility, and it's used to switch equipment line circuits in and out of service. There's interconnected facilities there, meaning we connect with another utility there. So we connect to our neighbors. And sometimes we have substations that are connected to DC converter stations all along here in the Midwest between Kansas, Colorado, Montana, Nebraska, those areas there. We have DC converter stations where we take power from the east, convert it, and send it to the west, or the west to the east. So most of the time, our switching is done in a substation. And how we do that is with authorized individuals. For example, what is a switchman? That's an authorized person who's been trained to do the switching and tagging operations. And some of those folks could be system operators, foremen, linemen, electricians, technicians, plant mechanics, inspectors, supervisors, and engineers. And when we're switching, it's all about protection, especially when we're talking about establishing a clearance on a piece of equipment. So all switching and tagging, logging, etc., performed to make a given piece of equipment available for workers to apply personal grounds to work under a procedure. So when it comes to switching a piece of equipment out for a clearance, it's all about what type of protection or visible open we can provide to them so they can, at some point after they receive their clearance, work on the equipment safely. So how do we maintain the reliability and integrity of the federal power system? Well, there's a couple things we'd like to think about. First of all, we have these 4 priorities, and they're listed in their importance. Of course, number 1 is the safety of the employees and our public. Number 2 is the integrity and reliability, the integrity and reliability of the federal power system. We want to protect our equipment and we want to serve the customers. Those are our priorities, because if we don't complete 1, 2, and 3, then we really can't get to number 4, which is serving our customers. So again, safety, of course, is always number 1. So with those 4 priorities in mind, there's a bunch of us that impact those priorities. And we start with a NERC certified system operator who's been qualified to work that electrical system. And they're kind of the focus point for all outages on equipment. And so there's some support staff that help the system operator operate the system reliably. And that's the outage coordinators, system engineers, study engineers, tech writers, switchmen, linemen, electricians, operations trainers. They train the switchmen, meter relay, communications, SCADA, construction, procurement, finance, leadership, USBR, the neighbors, and last but not least, there's a person out in the world called the reliability coordinator who oversees all of the interconnected system operations. But ultimately, it stops with the system operator. They're responsible for that reliability of our power system, but we all play a part in helping the system operators make the correct decision at the correct moment. So the first type of switching we want to talk about is a clearance. And again, this is a big part of our switching, is to establish these clearances so we can work on equipment. And so a clearance provides protection against interization from sources of our primary system energy. That's something that you'll hear throughout PSOM Chapter 1. PSOM Chapter 1 is our book that says this is how we switch at WAPA. And that's what we train on annually. And that's what we live by when it comes to safe operations of the electrical system. And so the clearances are achieved by systematically isolating all equipment to be worked on from all sources of primary system energy. That's electrical energy above 600 volts. And it's accomplished by providing a visually verified open point or a limit of protection. So in this photo here, you see the switchman Kyle. He's looking up at that 345 kV disconnect, and you can see that it's in the process of being opened. And so that disconnect right there will be used as a clearance limit. It will be open, checked open, locked, and tagged. The other thing we have out there is a hotline order. Notice how I didn't say the word protection. With a hotline order, you have no protection. The crew is going to work on or near the line while it's energized. Some of the times, the system requires that we work on equipment that is energized. In order to do that a little bit safer, we place a hotline order on the line. And what we do with that is we go in there and we take the automatic reclosing 79 relays and we turn those off. And so the crew will work on or near the line. The HLO supervisor will make sure the crew maintains minimum approach distance. Because if they violate the minimum approach distance, meaning they get too close to the energized conductor, they may flash it over. And so if that happened, we do not want to have an automatic test or re-energization of the line, because we'll hurt you once and then we'd hurt you twice. So when we have to work on equipment that's hot, we turn off the reclosing relays, the 79 relays, and then we place a hotline tag or light on the device. And then we go through this formal process of issuing the HLO supervisor this hotline order. And again, it provides no protection. It's just when we are forced into working on equipment that is energized, we establish a hotline order. And guess what the most important part of this is? Right after safety is constant communications between the system operator and the HLO supervisor. Another thing we have in the switching world is called general switching. And that's just switching that we use to maybe sectionalize or rearrange the system for a given operating condition or situation. A lot of the times we use general switching for meter relay technicians who may want to work on the relays. And so what we'll do is we have switching steps and a formal switching program, just like all our actions. And they'll go and they'll open the breakers and open the disconnects. Normally with general switching, folks will not touch the actual equipment. They'll open the disconnects, but they won't put their hands on the circuit breaker. And again, if we get into a situation where there's something we need to take care of that's below 600 volts, it's done with WAPA's lockout tagout procedure, or LOTO. One of my fan favorites is the authorization to work. It's not necessarily switching. However, it could impact the safety and the system reliability. So the authorization to work shall provide information to the system operator regarding all work performed on equipment affecting the power system. I remember a couple of years ago where the facilities folks were up on the roof above the control room and they were painting and doing some other things up there and sealing some things up. And guess what? All those fumes were sucked down into the air handlers into the control room. Now, did that impact system reliability when the system operators are choking and can't breathe because of fumes? Yeah, it did. Absolutely, it did. What if there was going to be some major work on a SCADA system? Should we fill out an authorization to work? Absolutely, because guess what? If something went wrong and the SCADA was to go down, then it would cause system reliability issues. Another favorite is if you're going out there and you're working on a battery charger or floating a battery, put her on equalized. Guess what? One of the most important pieces of equipment in a substation is the DC electrical system. That's how circuit breakers operate in a substation. It's okay if the AC system goes down from station to station, but if we lose our station battery, we cannot operate our equipment and it will not operate properly to clear the system if there's a fault on it. So that's another one that's near and dear to my heart, is the battery system in a substation. So when and where can switching take place? Just about anywhere. So one of the things I want to think about is the control center on SCADA. That's switching. Absolutely. The system operator, he's setting at his control center. He's got a switching program just like you right there in front of you. He's going through his switching step and you can follow him with his cursor on the screen as he selects the circuit breaker and opens the circuit breaker, opens the motor operated disconnect. Switching takes place in a control room. It takes place out on the transmission system where I have a lineman stand there getting ready to open a switch. Okay, switching happens during normal conditions and it happens during emergency conditions. You can switch in a substation, you can switch in a power plant. Sometimes we have to do switching because of equipment limitations, and we're trying to prevent overloads. So how do we coordinate with the field crews during emergencies and outages? Well, I'd like to say very carefully, with purpose. So what we need to do, especially in those emergencies or outage situation, you should have a general discussion with the system operator about the situation. Potential solutions. What are the problems? What are the solutions? Everyone's point of view. No one should be stifled. All shall be heard. The phrase of the day should be, this is what I know about the situation. Now tell me something I don't know. And that's very helpful because one member of the crew or one person in the control room could have that little bit of knowledge that will help the system operators make the correct decision at the correct time. And the other thing we talk about here in an operations world is three-part communications. Everybody's got to be on the same page. Three-part communication just doesn't happen from the system operator to the electrician in the field. If you have something that's absolutely important and it needs to be absolutely correct, demand three-part communications from the system operator. It's okay. We like three-part communications. So here's a picture of a system operator down in Phoenix, utilizing 6 basic steps of switching. He's always thinking about three-part communications. Well, what is a control center? Some people call it dispatch. It's a centralized location for information for more of the system operator. The more the system operator knows about the situation, the better decisions they will make. And you can see right in the middle of that screen, we've got a station 1 line display. And that's what the system operator switches from. In this example here, you have a couple of switchmen, and you can see where the switchman is pointing to the switchboard. That's what that is there with the red light on it. That's a substation switchboard, and you can see there's many handles there. So in a substation control room with all those handles, once you find your position on the switchboard, with your finger, you point or touch, sounds like the 6 basic steps of switching, point or touch the device nameplate to make sure it's your location. Keep your finger there. Look to your checker. Look on the switching program. Make sure you're in the right place, right location, right sequence, and then you perform the requested action on the device. See how I'm going through and talking about switching on a switchboard using the 6 basic steps of switching. In the substation switchyard, hey, you know what? This is a picture again down in Desert Southwest. Here's what I found out in Phoenix. There's a lot of interesting things you'll find in a substation, like spiders, scorpions, and snakes. The folks in Yuma were nice enough when I was down there, I don't know, a couple of weeks ago to show me some scorpions that, yeah, watch where you're walking in the substation, especially in the desert. So you got to realize when you're in a substation, all that equipment is set up to operate automatically. If there's a fault on the system, there's automatic relays that will operate out there, and equipment may open or close, and you're walking right next to it. So when you're in the substation or in a power plant to do some switching, just be aware of your surroundings, some of those hazards, and then also that all that equipment can operate and switch itself out of service automatically at any time. Out on the transmission line, well, there's a couple of things we can talk about out in the switching on a pole switch. First of all, you really need to think about what you're trying to accomplish and what do I expect to hear when I open that pole switch. Sometimes we have to open pole switches and de-energize sections of line. And what you need to think about if you're operating a pole switch is, what type of switch is it? How long of a line am I going to de-energize when I open the switch? And do I have anything that's mounted on the switch that will help extinguish the arc? We've had a couple situations where people have opened pole switches and the switches weren't designed or capable of interrupting that arc as they de-energize that line section. And what happens is you catch the top of the pole on fire and all that metal and aluminum will fall down on your head. So if you're a person that is required to switch on a pole switch, and I know all of our linemen are highly qualified and they know what they're doing when operating the switch, just think for a moment, what do I expect to hear when that switch operates? What do I expect to see above my head when that switch operates? How long is that line that I'm about ready to de-energize? Can the switch handle it? If there's whiskers on top of the switch, are they in place and are they still connected? So pole switching, it could be challenging. So switching under normal conditions, we have a switching program. Here's one from the Rocky Mountain region. This is brought to you by ITOA. A couple years ago, WAPA wide started the ITOA program. And so as you go from region to region as a qualified switchman, there's going to be a lot of consistency in what you'll see from a switching program. And so some of the things I think about when I look at a switching program is what version of the switching program is it? Is it the original version? Is it revision 1, revision 2? So when I'm a switchman and I communicate with the system operator, the first thing I do is tell them the program number. For example, C meaning clearance, 23 because it's 2023, and then the program number. It could be anywhere from 1 to 2015. They're listed in sequential order as they start through the year. So in this case of this program here, for example, C23, it could be program 144, and you can see up near the right hand where it says page 1 of 4, you can see that it's an original program. It's the Rocky Mountain region. And then it tells you what the equipment is based on the FID. And then there's a section called limits of protection. It tells you what is going to be the visible open for establishing the clearance. And the other neat thing is down here where the red box is near the bottom, a lot of the times we'll have emergency contact information in case there's a problem when someone's out working on a line and they need emergency services. If they call me in the control center and I dial 911, I'm going to get 911 in Loveland, Colorado, not 911 in Casper, Wyoming. So the other thing we're real particular on is the emergency contact information for where the crews will be working. And there's a couple other areas down there near the bottom that talk about special setups or special needs of this program, impacts the program may have. Now, I can tell you that once you submit an outage into operations and goes through the study phase, the planning stage, the switch writing, the outage coordination, all those things, your program is approved, but your program is not truly approved until the morning of the outage, because guess why? The system is always changing from when you submitted your outage to when the actual day of execution of the program comes. System conditions could have changed, and so that could impact your availability of taking your program out on the day that is planned. So switching in emergency conditions, PSOM Chapter 1, Section 1.6 says emergency authorized personnel may modify or suspend any of these procedures temporarily as necessary to permit proper handling of the specific emergency. Okay, and if you do have to do some emergency switching, make sure you keep safety in mind. All right. Make sure the situation is safe. If you find something going on and you take independent action, PSOM Chapter 1 says if you're authorized and qualified, you can do that. Just realize, don't put it back in. If you have to force something out, don't put it back in when you think it's safe. If you take independent action, stop and then communicate with the system operator. And in my mind, the only time I would see someone take independent action is if life is in danger. Now, one of the things you can do if you have to take independent action or you're called to a substation for emergency switching and you don't have a program, in the back of PSOM, Chapter 1, on the left side here, you'll see a switching program form. It's very generic. It can be for placement or for removal switching. When those system operators gives you those verbal steps, write them down. Write them down on that form. Pull that right out of the back of the book. Write that information down on the switching program form and go through the read and review process and repeat that back, 3-part communications, and make sure you have everything listed correctly in the correct sequence. So one of the things we want to talk about is equipment limitations. Like I mentioned when we were talking about pole switches, make sure the switch is designed to do what it's supposed to do, whether it's a pole switch, whether it's a disconnect switch, whatever the case is, make sure you operate the equipment within the limitations. Lines, transformers, we have disconnects on the high side sometimes of transformers that are made to de-energize the transformer. We have load break disconnects, we have fuse disconnects, we have motor operated disconnects. If you're told to decouple or make an operative lock and tag a motor operated disconnects, do I know how to do it? Well, how do I figure those things out? If my equipment is good, it's in service, do I know how to operate it? Does it look like it has the right pressures? Well, that's where this thing comes in called pre-switching inspection. And when you get called to a station for switching, whether it's routine switching or emergency switching, go take a look at that equipment. Take a look at the substation, make sure things are free of hazards, and you understand how to operate it properly before you go through the switching process. Again, that's called the pre-switching inspection. It's very important to successfully switching equipment. So what happens if equipment relays out of service during a fault condition? A couple of slides ago, I talked about when you're in a substation, there's hazards in there. There's one of the things is equipment can operate automatically. So the first thing that we do from a system operator's point of view is when equipment relays out of service during a fault condition, we perform a system assessment to make sure no other components of the system are being overloaded. If I have two transformers in parallel and one of the transformers trip, guess what? That load's still going to be served, but through the other transformer or maybe automatically through other transmission lines. So one of the first things we do as system operators is we perform an assessment on the system to make sure we're not overloading any other equipment. And again, if we do find an overload, then we're going to have to focus our attention on that. So there's a whole bunch of coordination that has to happen between the control room, the dispatch center, and the field, along with other utilities, customers, neighbors, engineering staff, the RCs, reliability coordinators may need to be involved. And depending on the nature of the issue, what the equipment is involved, a decision will have to be made. Are we going to test that piece of equipment? Maybe it requires a manual test. It depends on the type of relay targets we see too. It depends what tripped it. For example, on a transformer that relayed on differential, after we inspect it, we may be able to test it. But a transformer that relays on a sudden pressure relay, we won't be able to test it. We're going to have to do some actual tests on the equipment before we can put it back in service. So there's a whole bunch that goes into when equipment trips on a protective relay operation. So some additional thoughts when equipment relays out of service during fault conditions. Again, we talked about is there other equipment overloaded? Yeah, that's something to think about. But what have I just done to my neighbor's electrical system? Those overloads may not happen on my system. Maybe the least path of resistance is to go through my neighbor's system. So there are circumstances and situations in the system we may need to do some system rearranging, some general switching to alleviate overloads on our own system or overloads on our neighbor's system. Does the equipment need to be cleared? Do we have to switch it out now so we can perform a proper inspection? What if we find where the fault is and we have to take the line out of service? And so that opens up a whole lot of other opportunities to, I guess you could say, complicate that process. But again, it's not about speed, it's about efficiency. And again, all those folks that I called out in the first couple of slides of the presentation day help us make a better decision and in a timely manner to where we can operate and prepare the system to be fixed and put back in service safely. So when good equipment goes bad, some of the time equipment doesn't relay. Some of the time we'll have someone doing a station inspection and they run across a problem with some equipment, and then they call us up and they say, hey, I need to take this equipment out of service because of ABC or XYZ. And so what we will do, depending on the severity of the problem, we're going to run a study. And so what we do is that study, we take a look at the system with our real-time contingency analysis system study tool, and we say, okay, let's take a snapshot of the system. All right, here's everything that's flowing right now. Now let's remove this element. Okay, how does the system react? Where is the power going to flow? This is a requirement by NERC that we have to do those system assessments every 30 minutes. And so here's a situation where we found some equipment. It was good equipment, but it's having a problem. And then rather than waiting for it to fail, we're going to take some proactive action, and we're going to take a look at the equipment, take a snapshot of the system, and see how it looks. There's, again, with any type of problem, there's going to be a tremendous amount of coordination that has to happen with utilities, customers. Is it going to impact load when we take this equipment out of service? Do we have to drop load? Is it impacting maybe station service at one of our substations or a power plant? Those type of things. And if switching is required, we're going to have to make sure that the equipment is safe enough to operate, especially if we're getting into pressures on circuit breakers and those type of things. So the rest of the story here for our forced out of service when good equipment goes bad is, like I said, can the switching be done safely? Do I have time to write a switching program, or am I just going to switch on the fly with the switchman? Now, what happens when I say to a switchman, I'm going to need you to open this breaker, that breaker? Remember about 3 slides ago, I said in the back of PSOM Chapter 1, one of our appendices is a switching program form. Not all of our substations have computers or printers where we can print programs off from TOA, but there's no reason that the system operator can't say, grab the appendix out of Chapter 1, and I want you to write this down. And they just go through issuing those instructions, and then it'll say, hey, switchman, I need for you to repeat those back to me. And it's just like what we have called the read and review process, where the switchman reads me the steps, I follow along, and I say, yes, that's correct. And I give them permission to go do the switching. So if we're switching on the fly, especially in emergency type of things, don't hesitate to write that down on that appendix in Chapter 1. If you don't have that form, grab a piece of paper and write down what your switching steps are. You don't have to do it by memory. Okay. And the other thing we'll think about is, as we're doing that, can we wait on it? Can we wait till, if it happens at 3 a.m, does it need to happen that night? Can we wait till the next morning? You know, we kind of look to our field folks and others to help us make that decision. But if it's truly emergency, we'll do our study. We'll make some communication, some coordination with our neighbors and the reliability coordinator, and we're going to go ahead and remove it from service. All right, that's the end of my presentation. I believe it's now some time for some Q&A.
All right, thanks, Pete. You can go ahead and stop sharing your screen if you would like. Can you hear me okay?
Yep.
Okay, so I did get a couple of questions that came in. The first question, it was when you were on the transmission line switching slide. Is this the kind of switching they do for house moves?
That's a great question. Could be. Yes, but normally what happens when I've seen house moves, we'll actually put a clearance on the line and take the line down. So it could be if the house is being moved near a tap. But most of the time when it comes to house moves, what they'll do is they'll take the entire line out if at all possible. And really house moves kind of get more into the distribution circuits where it's on the wood poles versus a transmission tower, that type of thing. But usually when it comes to house moves, what we have to do is we have to de-energize it, put a clearance on it, and drop the conductor, and then cable TV has to come out, you know, communications guys, and move those type of things. The poles will stay, of course, but a lot of times when it comes to house moves, that's real popular here in the Midwest. We'll have to take everything down and de-energize it all and put clearances and those type of things. Hope that answers the question.
Yeah, thank you. All right, so the next question is, How does someone become a qualified switchman?
That's a great question. So to become a qualified switchman, well, there's a couple different ways. Normally, our craft folks are journeymans, lineman, electrician, those type of things. And so what you do is when you're hired by WAPA, you're deemed as a craft person. And what you have to do is WAPA offers a 2-day initial switchman training class. And what we do is we take you into the substation. We cover PSOM Chapter 1 from front to back. We talk about PSOM Chapter 8, which talks about substation numbering type of things. And then at the end of the 2-day class, it's between the switchman trainer and that person's foreman to where they determine that, yes, you meet the minimum qualification to become a switchman. And a lot of times what we do is once we train you in that 2-day class and you go out and you switch, we ask that you switch in pairs with a more experienced person so you can kind of perfect the skills that you just learned in class. And so that's normally how you become a qualified switchman. And so, and then PSOM Chapter 2 requires that every year, all the qualified switchmen have to go through an 8-hour class on tips and techniques and PSOM Chapter 1 to maintain proficiency on switching.
Great, thank you. Okay, next question. This one's relatively simple, I think. So when you refer to a system operator, is that also considered the dispatcher?
Yes, system operator and dispatcher is one and the same person.
Great. All right, next question. How long does it take to complete the 6 steps of switching?
As long as you need it to take. Obviously, a system operator who switches 10 or 12 programs a day becomes very proficient with using the 6 basic steps of switching. And so really, we just recorded a new switchman training video with Alex from Public Affairs down in the DSW region about a month ago. And so that'll be out here shortly. And in there, you'll actually see a switch on a couple of disconnects. And I would say it probably takes you to complete 1 step on the switching program form in the field, utilizing the 6 basic steps of switching. It'll probably take you 2 minutes.
Very good. Okay, next question. Is time of day a consideration for some kinds of general switching? It appears a lot of it occurs very early in the morning. Does it matter whether it's for the EHV system versus the lower voltages?
Okay, that's a great question. So if I understand it correctly, it says when you're doing general switching, a lot of it seems to start in the morning. And does that really matter? And it doesn't matter whether it's the extra high voltage, that's what EHV stands for, versus something that's lower voltage like 12 kV or 69 kV, that type of thing. And so what we experience every morning is what we call in system operations the morning push. Everybody wants their equipment switched out at 7 a.m., for example. And if you have 15 programs, it's hard to do 15 programs at one time. And so something that our system operators and our outage coordinators have been working really hard at is staggering those start times. But normally things start in the morning because that's when people go to work. And then usually in the afternoon time frames between 3 and 5 or 6 is when people are putting that equipment back in service. Now, to address the EHV part of that question, really, as the voltage gets higher, it gets more complex to coordinate that outage and take it out of service. Why? Higher voltage, especially something that's series compensated, like what we were looking at Pinnacle Peak on the 345 between Flagstaff and Pinnacle Peak, that's series compensated. So when you have series compensation, it allows us to transfer more power. And so that's what the EHV system is to shove that bulk power around and sell it and wheel it. And when one of those elements are out, people aren't real happy about it, but maintenance has got to be done. So the higher the voltage, the more challenges we are faced with scheduling and getting those higher elements of EHV out of service. I hope that answered your question. It was a good one.
Good info, thank you. Okay, so the next one is, Does the information in ITOA tell you which breakers need to be opened to affect an outage on a transmission line, for instance?
Okay, so the question is, does ITOA tell me which breakers I need to open to clear a piece of equipment? No, that's where the system operator comes in, and that's also where the requester, the person who's requesting the outage, which is a field individual, what they do is they look at where they have to work, they look at their SYD prints, which is a system single lines, they say, I have to work right here. Okay, so if I need to put a clearance on it, which equipment do I need to operate to open to establish a proper clearance and work on it safely? And so they take their best bet and they say this breaker and that breaker and these disconnects, because it's got to be a visible open. And then what they do is they put that information in ITOA, submit it to the outage coordinators. They look at it, they pull out their print, they see where that individual is going to work, and they say, okay, he said this, this, and this. Oops, he missed one right here, because we are our brother's keepers. We take care of each other. And they go, okay, that's almost right. They need one more disconnect. And they may reach out to the person and say, hey, you asked for this, but I think you need this. Do you agree? And they'll say yes. And so really it's between the requester and the outage coordinator. And then when the program gets to the system operator, it all stops right there with them. It's their responsibility to make sure it's adequate for the work being performed. So it's actually a human that makes that decision, what equipment I need to operate. And of course, the equipment is found in TOA.
Excellent. Thank you. Okay, so hopefully this is an easier question. What's your favorite part of your job?
You know, I guess my favorite part of the job is just the relationships I've developed with different folks at WAPA. I mean, I know everybody says we're a good company. We are, but yeah, you're right. Working with Mark Desmarais, that's probably my favorite thing. No, it's the people and the relationships I've established in all the WAPA regions. It's enjoyable. I really enjoy the people.
Me too. It's one of my favorite parts too. All right. So it sounds like communications is extremely important to do in switching. What challenges do you run into in regards to communication?
Right there. Listen with understanding. Challenges I have with communication is let's all be quiet for a moment and listen to hear what you have to say. Not think about what I'm going to say to you. Is stop, clear your mind, and focus on what's being said to you and process it before you engage your mouth. That is a challenge I find in communicating effectively. And I'm guilty of both things.
All right, so next one. Do any of WAPA's BAs accept switch person reciprocity from other agencies or companies, or do we require all WAPA training and refreshing for outside agency switching?
Okay, so I think what the question is saying, and let me rephrase it, and whoever that was can tell me if I'm correct. Do we accept any other company's switchman certification or training program? And do they accept ours? There are some companies out there that we accept. For example, Basin Electric, they do switching that's very similar to us in this area here of Colorado and Wyoming, and also down in Tri-State. If you look at the Tri-State Manual, which is a utility here in the Denver area, their switching book is very close to what PSOM Chapter 1 is. So there are some utilities out there that accept our switchman certification and training, and we accept theirs.
Excellent, thank you. Okay, here's another question. What's a visually confirmed clearance?
What is a visually confirmed clearance? Well, there's a couple of terms in there I'm familiar with and a couple I'm not. So I guess when I think about a clearance, in order for a clearance limit or limit of protection to be adequate and to be a a bona fide clearance limit, it has to be a visual open. Okay, it has to be open, locked, and tagged. And so what you need to do if you're in a substation and you're going to take a clearance on a circuit breaker, once the switching is completed, it is expected per chapter 1 that the clearance supervisor will go out and walk the clearance limits. What that means is that clearance supervisor, before he gets his clearance from the system operator, will go out with the program and say, this is the breaker I'm working on. Here's one limit over here. Here's the number. Here's the tag, verifying it. Then they'll go over to the other disconnect and say, yep, that's it. That's the number. See how I'm touching and pointing, just like my 6 basic steps. There's the tag number. Yes, it's open. It's locked. It's tagged. There's my equipment. Yes, I feel it is in the condition to where I can test it dead once I receive my clearance, and I can test it dead, hang my personal grounds, and go to work safely. So the question you threw at me was filled with some different terms, but I believe that's what you're asking me, and that's what PSOM Chapter 1 says.
Excellent, thank you. Okay, I believe this is our last question. It's interesting because it's kind of the theme of all the news and everything you're seeing lately. Do you ever foresee AI/chat GPT taking over a switch person role?
So are you asking me, do I ever expect to see a robot switching?
Yes.
Maybe, who knows? You might. I think we're still probably a few years away from that, but the one thing I want you to take away from here is, if you are a switchman, don't become a robot.
Great summary.
Be a thinker. Be a thinker. I
Okay,
saw a question.
I was going to say, we got another one that popped up. You keep mentioning PSOM. What does that mean?
PSOM is Power System Operations Manual. There's about 8 chapters of it. Chapter 1 is the switching book that we use to switch here at WAPA. PSOM, Power System Operations Manual.
All right. You know what? There were a couple more that I didn't quite get to. So here's one more. What is an interconnected clearance and when is it used?
Okay. Interconnected clearance is a clearance between me and my neighbor. So we have transmission lines that tie us all together. And so if I want to work on my section of that line, I'll reach out to my neighbor, following the proper outage coordination guidelines, of course, and I'll set up a clearance between me and them. And that's what an interconnected clearance is. It's between you. It's a clearance between you and your neighbor.
Got it. Thank you. Okay, the other one is, who's responsible for ensuring a switching program is correct?
Every person involved in the process. It all stops with the system operator, but the outage coordinators have a responsibility. The system operators do. The first checkers, the third checkers, fourth checkers on a switching program, and the switchmen have a responsibility to make sure the program is correct and will do what we're trying to do.
Perfect. Okay, and I think you sort of touched on this before, but just to go a little bit deeper, wondering about, how you get into this line of work as far as like special degrees or certifications, maybe before you get to WAPA.
Okay. So a couple years ago, we started partnering with Bismarck State College in Bismarck, North Dakota, and they have an energy program up there. They have power plant, they have substations, they have a lot of the trades at Bismarck State College. And so there are times when we have trainees that we hire and we run them through the Bismarck State College. And so just go to Bismarck State College, Google that, and look at their energy programs. They actually have an 8-hour switchman training class. And guess what book they follow? PSOM Chapter 1. Yep. So there's other folks in the industry who have adopted our switching book, PSOM Chapter 1, and they follow it.
Excellent. And I think just one more question related to that. Is there a craft training program here at WAPA to become a switch person? And I think you did touch on this maybe a little bit earlier.
So at WAPA, there is a craft training program, and that's separate from system operator training program and system operations. But your regional trainers, there's, probably about 8 of us at WAPA. We do the switchman training for new switchmen and annual refresher. Plus, also, we've partnered with the EPTC, Electric Power Training Center, Kyle down there, and he's got like a 4-day class where you can go down there and take some switchman training. So yeah, there's a couple avenues at WAPA to become a switchman.
Excellent. Thank you. Lots of interest in that area, it seemed like. So, all right. So with that, I will go ahead and wrap up our Q&A session. Pete, if you want to go ahead and share your screen again, I'll turn it back over to Lisa to close us out.
That is our presentation for today. I want to thank Pete so much for sharing your expertise with us and for answering all those questions. Thank you, Katie, for helping with the Q&A. You both did an awesome job. Thank you to all of you who joined us today. We really hope that you enjoyed this presentation. And just as a reminder, the video of the presentation and the presentation slides are going to be posted on the MyWAPA page soon. You can find a schedule of our future open mic presentations and any recordings of past presentations on the open mic webpage. So if you just go to the MyWAPA page, follow the link under programs, and then go to Integrated Communications Group, and then on to the open mic from there. There will be a survey that will go out by email following this presentation. We would love it if you could just take a couple minutes to share your thoughts on the open mic. This just helps us improve our efforts for future sessions. I also would like to introduce our next open mic presentation, which is scheduled for next month. Alan Turner from the Rocky Mountain region is going to be sharing about the Granby Windy Gap line rebuild and substation construction from planning to closeout. So be sure to watch for more details on that, and we hope to see you all there. Thanks again, Pete and Katie and everyone else listening in. I hope you all have a great rest of your day.